Hey guys, it's Erica. I'm an SAT math tutor. Let's do this SAT geometry problem. This is a problem from the domain geometry and trigonometry. The skill is right angles and trig, and it's a hard question. Maybe it's not hard for you. We don't know. We don't know these things. So I am sick, so I'm not gonna read it to you guys. Just pause the video, read it to yourself, and then come back in 3, 2, 1. Okay, let's jump into it. So some things to note about this problem. The first thing is that these triangles are congruent equilateral triangles. Equilateral meaning each side of these triangles is the same length. Okay, they're all equal lengths. The next thing to note in this problem is that the perimeter of the logo is 20 centimeters. What that means is the perimeter of this shape is 20 centimeters all the way around, okay? And they want to find the combined area of these two triangles. So essentially what we want to do is find the area of each triangle and add them up, okay? So the area of a triangle is 1/2 base times height. And we have to basically times 2 because we have two triangles. So the things that we need to find, let's do like this. We need to find the base of our triangle and the height of our triangle, right? So how do we do that? Well, we use the perimeter. Whoa. We use the perimeter. The perimeter all the way around is 20, like I said. Each one of these is going to be the exact same length. So what we can do is do 20 divided by 5 because there's 1, 2, 3, 4, 5 lengths that make up the perimeter. 20 divided by 5 is going to give us 4. So that tells us that each side equals 4. Wow, how convenient is that? Now, we're looking for the area of the triangle, so let's pull this guy out, okay? Just so we can have a clear picture. Yeah, let's try to make a nice little triangle that looks kind of equilateral. That's fine, okay? So this is going to be 4. This is going to be 4. We need the base, which we already have, right? The base is here. So let's rewrite this equation with the base, 1/2 base. But we don't have the height, okay? The height of a triangle is going to be this. It's not going to be the hypotenuse. It's going to be this. It has to bisect the base. And this is going to be a right triangle here. Oh my gosh, how convenient. We love right triangles, okay? The reason why we love right triangles is because we can use the Pythagorean theorem. So this is 4. Now, remember, this got bisected right in the middle, and this whole thing is 4. So 4 divided by 2 sides is going to be 2, which means this is going to be 2. Does that make sense? It's 2 plus 2 equals 4. Okay, so now we have 2 of the 3 sides. We can use the Pythagorean theorem. A squared plus b squared equals c squared. Let's make this a squared over here. So we're going to have a squared plus 2 squared equals 4 squared. So a squared plus 4 equals 4 squared is 16. 16 minus 4 is going to be 12. So a squared equals 12. And then in order to undo the square, we're going to square root both sides, like so. So we've got a equals square root 12. Now, that is the height. Remember, we're just solving. Oh my gosh. I'm so sorry. This is a square because I got confused. That's just a. All right? That's just a. Anyways, it's a, but now it's square root 12 because we found out that a actually equals square root 12. Now, that is the height of this equilateral triangle here. So we can go ahead and plug that height right there. Okay, I'm going to erase this, so go ahead and take a screenshot if you need, or just pause it and write it down. All right. So now we have everything for this equation. So we have a equals 1/2. The base of our original equilateral triangle is 4 times the height of square root 12. We're going to simplify this down. 1/2 times 4 is going to be 2. And that's just going to be times square root 12. That's the area of one triangle. All right, remember, we need the area of 2 triangles because that makes up this logo. So we're going to do this times 2. I'm going to erase some more stuff just so I have some space. So we're going to do the area of both triangles is going to be 2 square root 12, which is just the area of 1, times 2. So 2 times 2 is 4. Square root 12. Now, does that match anything? No, it doesn't. One thing you can do is you can find the decimal of 4 square root 12. If you don't feel like reducing the square root 12, that will be 13.86, and then you would just find the decimal for all of these guys and see which one matches. If you're like, hey, that takes too much time, okay, let me show you how to reduce this 12. So we're gonna have 4. What you want to do is you want to essentially expand 12 into prime numbers. So I like to just divide stuff first. So 12 divided by 2 is going to be 6 times 2. 6 can be divided some more. So let's do 3 times 2 to make 6, and then bring down that other 2. Now the key here is we want to make pairs. So we have 2 and 2. The reason why we want pairs is because we want to square something, because the squares cancel out the square root. So let's move this way so we run out of space. 3 times 2 squared. This square cancels out the square root over the 2. This guy goes away. So we can say 4, and that 2 got pulled out. Oh my goodness, pulled out, and the 3 is still stuck underneath the square root. 4 times 2 is 8, square root 3. And that's going to be C. If you're like, absolutely not, I'm not doing that, that's fine. Just find the decimals like I showed before, so you can find it that way. Or just throw it into Desmos to see what happens. But that's the answer, C. Good luck studying, everybody. Tomorrow is May 3rd. The May 3rd SAT? Is that today? Yeah, May 3rd is tomorrow. Good luck. Make sure you get good sleep. Don't stay up all night studying, okay? Your brain needs rest, and it needs food. Don't forget to eat, and take deep breaths before the exam. Okay? Your brain can't think if it's freaking out. Okay, let me know if you guys have any questions, and if you would like some private online SAT tutoring, the link for that is down below. Okay, happy studying!